Hello guys, this is episode 8 of System Design 100, and today we're going to discuss about data centers and geo routing. So I'll just write it here. Now, till now, what we were discussing was that this particular architecture, oh, I think I missed something. I missed to add the session data storage, right? Okay, this is our session data. Okay, so till now what we were discussing was that but the whole of our architecture, whatever we were designing, was for a single data center. That means for a particular location. All of these were present in a single data center, and we were not considering that our application will be used in a very wide area like a country or multiple countries. So generally we were using a single data center. So for example, let me think about any of the solution which whole country can use. So uh, streaming services, any OTT, whole country was. For example, we have OTT services like country specific like Z5 or Sony Live. These are specifically designed for India, and these OTT services host services and products that are only meant for India only. Okay, now India is a very huge country, and we have a lot of users spread across India. We have some in northeast, and then we have in south, and then we have in north. So having just a single data center, for example, this data center is located somewhere in north, in around you can say Gurugram. It is located in Gurugram, and all of our infra that we are designed is located in Gurugram. But the users are spread across India, right? So we have users coming from south as well, and then northeast as well, and west as well. So the users that are located closer to Gurugram, for example, specifically the people in the north and northeast as well, they are quite closer to Gurugram. So the response time for them would be very less. They won't face any kind of stream issue or lag issue, because they're technically situated very closer to the data center that is serving all this. Okay, it's simple logic, right? The closer you are to a particular network, the faster speeds you'll get. So the users in the north, and specifically who are very closer to that particular data center, but closer to Gurugram, will get very good speed, will get very good response time, irrespective of the internet. And the users that live on the southern end of the country, they will definitely get lower response time, because the data center is very far away from them. Okay, in that case, what we generally do is we replicate our environment across data centers. So if I try to create this in form of an environment, so this particular environment, you can take it as uh, okay. So this is North North India 1, and it is in Gurugram. So this particular environment is stored in Gurugram. Okay, what we'll do, we'll replicate the same architecture we have, exact same architecture in the southern part of the country. Specifically, for example, you can take Chennai. We'll do it in Chennai, exactly same architecture. Just give me some time. Okay, I need some time to design this. So yeah, I think this is perfectly replicated. Okay, this is South India 1, Chennai. Okay, so now we have exactly two exactly same architectures deployed into different part of the country. So since we can have multiple data centers across country, it's not only that we can deploy them in North India and South India. We can deploy it in somewhere in the central India also, somewhere in the northmost point of the India also. In the west we have Gujarat. We can deploy the same infra there as well. In the northeast we have something called northeast. We have Kolkata. We can deploy there something there as well. So we can replicate this particular environment with a particular infrastructure across India, so that all of the users get a very equal amount of very equal amount of response time, or all of them get very good performance out of the application. Okay. Now the question will let how will the routing, or how will the DNS decide that which users will be routed where? Okay. So if you remember, I in the very first episode I told, right, there is something called a routing table like this. There is a routing table created for IP. So our server IP, for example, for the north is something called 192.168.1.1, and for south is 192.168.1.2. Now, for example, we are doing sonylive.com. Now, there are internal ways in which a DNS can do geo routing. It's not very difficult. So taking input your IP addresses and other data, that when you visit a website, they get to understand your IP address and other data. Depending upon that, they can very easily route your request from they can very easily route your request either to the north service or the south service. They have very simple techniques. It's not very difficult. Okay, it's very easy for them. So first solution is that using the DNS that we use, generally we can route our services either to the southern part of India or to the northern part of India, depending upon various states. If you are in MP and Rajasthan and Chhattisgarh, states like this, which are closer to North India, your request will be routed to north part. And if you're in the states like Kerala, Karnataka, Tamil Nadu, and Telangana, so your request will be routed to this particular data center. Now, one other service is also available. It's called a geo load balancer or a global load balancer. It can be created just above these load balancers. We have typical you can say data center specific load balancer, which can balance traffic load within the data center, and then we can have a global data center. And then we can have a global load balancer which can route traffic across multiple regions. So instead of sending request to this, users request will be routed to geo load balancer, and geo load balancer can route traffic to different data centers depending upon whatever our similarly in that way, depending upon our metadata, whatever we get, whatever that server stores, our IP address and other data as well. Okay. So these two solutions we have, you can implement any of these two. These two will work almost exactly the same. You will not have very much difference between these two. Within load balancer, you have to define routing rules. Similarly, you define routing rules. You can define routing rules there as well. So both of the solutions are very much fine. Okay. Now, I was telling you about the benefits, right? So the one of the very much benefit is that the users from south will get better response time because their request is being routed to a data center that is nearby to them. Similarly for the north. The second benefit that I see is called data localization or data synchronization. So we can divide our data depending upon the particular region that it is stored in. For example, if I take example of Sony Live only, people from the south generally prefer that the movies from the south only, or the movie from Tollywood, and people from the north generally prefer the movies from Bollywood. It's the trend is changing nowadays. People are watching southern movies and Bollywood movies equally across India because dubbing is very common now. But I'm just giving you an example. Okay, so we can definitely there is a technique called sharding, which we're gonna study later on. I think 2 or 3 videos later than this. But in what do we in sharding? We divide the data so that the load between databases can be partitioned also. So the load between databases can also be divided. So specifically, I can store movies or data related to north in this database, and I can store movies related to the south and particular preference of the people of the south in these databases. So our data is also divided, and the load is also spread across both of these data centers. So both of these architectures can work even better because the load on both of these architectures are divided across these two parts, right? So when I was talking about the data getting divided, it is one of the solution. But generally, in case so when we are talking about content, right, we do not use sharding. There is a little bit advanced technique. It's called data cool and hot databases. Okay, so it's a technique in which you decide what kind of content will be stored in an archival database and what kind of content will be stored in a database which gets accessed very frequently. So specifically in Node, the particular content that the northern people prefers can be stored in a hot database, and the particular data and the other data can be stored in a cold database. We can define that kind of a strategy across our data center. It's a little advanced topic because it when you're designing very huge application, defining the data storing and archiving can store a lot, save a lot of your money. So we can define something like that, but yeah, do not confuse about that. Okay, these two databases can be equally replicated, and these two will contain same kind of data. Okay, now one other benefit, or one other I can say one other benefit of creating your infrastructure in multiple data centers is that you get something called a disaster recovery, or you can say more availability. Now, for example, if I talk about South India, Chennai, right? Chennai is a coastal city, and it's very common for Chennai to experience very high amount of rains, or even sometimes cyclones hit so the southern part or the eastern coast of India. So the power or anything can be disrupted in this particular city. So it's very much possible that the data center stops working for some time because due to electricity loss or due to floods, anything. It's very common. We have seen a lot of the time Chennai getting hit with floods and everything, right? For example, Chennai is hit with floods and electricity goes out and this data center stops working. Okay, and our connection is cut here. So how there is a way the load balancer decides. There is something called a health probe within a load balancer, which constantly checks the connection between the multiple backend pools we have. For example, in this case, we have multiple data centers. So when it will check, send a health probe to this particular data center, it will not receive anything, and it will decide that this is not working. What this load balancer will do, it will route the traffic onto this database only. Now, people from the south will be routed to north only. This may cause them to get a high response time, but at least the service will work. Okay, it's not like the service will go down just because the data center went away. They will still be able to access the application even though one of the data centers is not working. The same technique can be routed in the DNS also using health probes. So health probes generally, what do load balancer do? For a certain interval of minutes, for example 5 minutes, 10 minutes, they send health probes to the particular backend pools, in this case the data center, and if they receive a 200 message in return, they route traffic to that particular data center. Okay, so this is one more benefit. And yeah, I think I forgot about this. I attached this what do you call it, the session data particular to the north, right? It's not like that. Since we treat user data as a central data, because user data is not different across regions, right? So generally we keep our session data separate from any region or any region specific data storage. Okay, so we keep our session data separate. It's more of like a global storage. Okay, so both of these data center can have a same session storage. Okay, so yeah, I think this was it, guys. This was episode 8. Thank you very much.